So this, we have the integral of secant to the fourth of x times tangent of x with respect to x. So obviously this is not one of the original six, right?
It's power rule.
It's not sine, it's not cosine, it's not secant squared, it's not cosecant squared, it's not secant tangent, and it is not cosecant cotangent. It's not one of those six. So because of that, it's not a true trig problem. It has to be a power rule problem. So we need to rewrite it and look at it as parentheses to a power. So secant to the fourth, I'm going to rewrite as secant of x to the fourth. Then I have this tangent out here. And in order to add 1 to that power and divide by the new power, I have to give away the derivative of the inside to reverse the chain rule and appease the integral gods. However, I don't have enough. I need to give away I need to give away
Secant times tangent.
what's the derivative of secant of x?
Secant tangent.
Secant x tangent x. So the derivative of the inside here is secant x tangent x. And I only have right now a tangent x available. But I have 4 secants there, right? So could I just borrow one?
Yeah.
I mean, really, that's just secant x, secant x, secant x, secant x times tangent x, right?
Yep.
Yeah.
So I could just write it as secant
To the
x cubed and borrow one of those and give him to the integral gods. I mean, it's unfortunate for that secant that he has to be the one to get sacrificed, but it's for the greater good and all, right? Right. So, everybody understand what happened?
Yeah.
Now I have the entire derivative of the inside of that parentheses. So if I see this is u, this is my du. And he goes away. And when I give away the derivative of the inside of a parentheses, that gives you the power to just do the power rule, regardless of what's inside it. So this will end up being secant to the 4 all over plus c. So we could leave it like that, but your textbook is probably going to rewrite it like this. They'll probably get rid of the parentheses again at the end and just write it in shorthand notation. Any questions about that one? Are we sure? Okay. Okay, so for this guy, we have the integral of negative cosecant squared of x multiplied by the fourth root of cotangent of x. So the first thing I did was I looked at it as negative cosecant squared of x multiplied by cotangent of x in parentheses to the what power? 1/4 power. Okay, so one of those parentheses we hope is the derivative of the other. And I hope it's not the one with the 1/4 attached to it, because I've never seen that kind of derivative before. So do we agree that the derivative of this guy is this guy?
Yes.
So he's the one I'm going to keep. And he's the one I'm going to sacrifice. And if I make this exact sacrifice right here, what does that give me the power to do?
Integrate.
Integrate using what?
Power.
The power rule. So I am now allowed to apply the power rule to that parentheses regardless of what's inside it. So we'll add 1 to the power. That will be cotangent of x to the multiplied by 4/5 plus
C.
the constant of integration. And we could stop there, or we could go back to radical form. 4/5, and we'd have the fourth root of cotangent to the 5th power. I just wanted you guys to see what that radical would look like and make sure you understood it.
Sweet.
Is that good? Okay, so for set 2, and you need to have most of these worked through next time so we can talk about them. Go back, and you might have had some trouble working problem 5 in set 1, but you should be able to do it now. And then 43 through 56 all. And if you'd like, before you leave, you can get the solutions out of the blue solutions manual back there, because some of those are even problems, and you won't have them on couch chatter in the back of your book.